Hey folks, Kevin here. Well, it's April 13th, 2020. It's a pretty big windstorm going on outside, so I really can't work out in the food forest. So one of the things I wanted to do today was share with you a paper that I ran across after seeing a video from Kim Iverson, and I'll put a link to the paper and to the YouTube video from Kim in the description below. But first, before I go into the paper, I thought I'd just mention a few things. So one of the things that we're always trying to do is get testing in order to identify those people who have been infected or currently have an active infection, and that's a PCR test where a nasal swab is placed up the nose. It looks for the presence of the virus itself, and it's in small quantities, of course, in most cases, and then that's amplified through this this PCR testing method. And the limitations of the benefit of this test is it can tell if someone actually has an active infection and they are shedding the virus. That's really super important, and that's been the first wave of testing that was developed. Another form of testing that is being developed and has been developed is a serologic test, where they take a small blood sample and they look for the presence of antibodies or immunoglobulins in the blood. It's important that the immunoglobulin that they look for is an IgG as opposed to an IgM. The IgM is a relatively immature. It comes in the first phase. It isn't immature. It comes in the first phase of developing an immune response to an infectious agent. The longer lasting immunoglobulin is an IgG. So hopefully the serologic testing that is being done is looking for the presence of the IgG antibody in person's blood. Now, what's the benefit of having this serologic testing? Well, this serologic testing can identify those people, especially if it's an IgG, that were infected with a specific infectious agent, have mounted an appropriate immune response, and have successfully eliminated that infectious agent. That's why the IgG is more important than the IgM, because the IgM could potentially, the patient could still be shedding and may not have a long-lasting resistance to that infectious agent if it were to have a second wave come through. So the IgG infers to us that that patient or that person had the infectious agent, has recovered completely, whether it was severe or mild or asymptomatic. They have recovered from that infectious agent and probably has very long, a long duration of being able to be exposed to it again without any becoming infected again. They would get infected, but the antibody response would be so massive and go after it, it would eliminate it, nip it in the bud right off the bat. So they would not be a person that would shed the virus. They could technically get infected again, but the antibody response could nip it in the bud right off the bat because it knows it. All the warriors are ready to tackle and take care of that invader right off the bat. So having good serologic testing tells us that, geez, this person can go back to work, this person can be exposed to other people, they aren't a threat to anyone else, and they are no longer susceptible to becoming infected themselves. So that's where everything starts off, and one of the things about some of these viruses is they have the ability to mutate. And depending on the, and these are RNA viruses as opposed to DNA viruses, and these RNA bases, and there's just 4 bases that are put in a certain sequence that are read by certain molecules within the cell and make the various parts of other viruses, whether it's the envelope that goes around the outer part or whether it's the RNA that goes inside of it. Well, since they're simple RNA viruses, they have more of a chance of mutating more frequently. And that doesn't mean that the mutation is survivable or has the same amount of infectivity or virulence. So let me say a couple of things here now before I finish that thought, because it just dawned on me. When I first took infectious diseases, one of the first lecturers, Dr. Campbell, explained it to me years ago during the lecture. He said it's sort of like a balancing scale, like the scale of justice. Whether you're going to get infected, how severely you'll get infected, no matter what the infectious agent is, whether it's a virus, a bacteria, a protozoan, a parasite, whatever it is. So certainly on one side of the scale is the health of the individual. Do they have any other comorbidities? Do they have any other disease processes? And in this case, you know, we could think about diabetes, hypertension, cardiovascular disease, kidney disease, cancer, did I mention cancer, or any of the, or obesity or smoking, any of those things. So the healthier that the individual is, and in the United States we have lots of health problems, and so the healthier that the person is, the higher on the scale it is. It's going to be tougher for that infectious agent to do severe damage or kill that person. On the other side of the scale is not only the virulence, how nasty and aggressive, how much it has an affinity for certain receptors inside of the body. Like, for example, this one that attacks these ACE receptors inside of the lower airways. And because of its proximity and how fragile that tissue is, there's fluid and fluid with its proteins of plasma that gets into those lower airways, and you can't breathe. So you don't get oxygen. The whole body suffers as a consequence of that. So not only is the virulence on this side of the scale so important, but also it's the dose of it. So even if it's a really virulent infectious agent, if you only get a few of those virus particles, it isn't as, your scale on this side, as long as you're real healthy, you might get over it just fine. But if you get a huge dose of it, in other words, you're not practicing social distancing, you're right up sucking face with someone who's severely ill, well, then you're going to get a heck of a dose. And if it's really virulent and you have any other morbidities, any other problems in your life, well, then the virus is going to win in those cases. So that's important to think about when we're talking about the relative virulence of the infectious agent and the dose of it, as well as our health status. And as I've talked before, my ethics are self-care, earth care, people care, and future care. All of those come into play when we're dealing with infectious agents that are transmissible, especially through respiratory secretions, aerosolized. So one of the things with this study, and I mentioned, I became aware of it last night by Kim Iverson. I'll put a link to that in the description below. And I asked her to provide me with some links to the articles she was referring to, and she posted those in her description. So I'll show you one. This is I'm going to call it a preliminary study. And it's really important that you realize that lots of papers that initially get submitted for peer review have holes in them based on the materials and methods, the statistical analysis, a whole variety of things, whether they have something to gain if they're disclosing, their relationship. And in this case, I don't think that's the case. But you need to have peer review by having experts. You need to have statisticians, people who are experts in these various fields of research. So this paper was published, or hasn't been published, but it's going to be published potentially in the Proceedings of the National Academy of Sciences of the United States of America. And this is a phylogenetic network analysis of this SARS-type infectious agent. And when I say phylogenetic, what I'm referring to in these cases is how we name the relatedness of various species. So you may be aware that some species names, the common name, whatever, of a plant or a mammal or a bird or whatever, the common name usually doesn't change, but the scientific name may change. Because years ago, people didn't have the ability to look at the genetic relatedness of various species. And based on looking at the genetic relatedness, we can have a more accurate picture of the tree of development from the original species that started things off and where each species branched off. When we went from vertebrates to various, whether they're mammals or the birds or the reptiles and so on. And then each branch branches out from there. So the genetic research helps us to look at how closely things are related, and it's with timing as well. There's a temporal relationship when we look at these things. So what this paper looked at was a relatively few number of people, but these were people with acute respiratory distress syndrome. 160 patients were looked at with their complete genetic sequence of the virus particles that were in them, and they were amplified and looked at. And what they've seen is, or what they're discussing in this article, is that there's an A type, a B type, and a C type, and they're making some suggestions about how closely related they are. So what we're talking about is an RNA virus can mutate and become less virulent or more virulent, or find a new way of spreading as well. So sometimes it's just spread within 6 feet, the droplets that come out. Sometimes it could become even smaller particles that are suspended in the air longer and all. And it may have less of an affinity for those receptors that are in our lungs versus a higher affinity. It may make a different surface molecule on our host cells as well. So there's a whole bunch of possibilities of ways that invader can either become more aggressive and more dangerous, or less aggressive and less dangerous. And when they look at the geographic distribution of these 3, A, B, and C, they can see the distributions between some of the particles that were identified in patients on the west coast of the United States versus those on the east coast of the United States. Like New York City, it really hammered everybody there very well. Now certainly if I go back to the scale analogy, in New York City, where in these metropolitan areas, people live in such close proximity. There's such close proximity that it's much easier to transmit the same type of infectious agent with the same virulence and same reproducibility in a higher populated population that's having more social contact or close proximity contact than it is in a more rural area like we are. We're out in the country here. So initially that might have been the full thought. So, and I don't want to go on too long with this video, but the thing that I would suggest is we really need, I hope America really gets very serious about this and recruits some of the best scientists as well to try and tackle this issue so that we can find out, do we need to do different PCR tests and serology tests? And is the patient who's recovered from a less virulent strain of this virus, are they resistant to the more virulent strain of the virus? Because once we open up our society again, especially international travel and all, there's more exposure to these ones, and there could be waves followed by waves of various infectious agents. So it's so important for our government to invest in the funding for further research looking into these various subtypes of these viruses, and making sure that our testing covers. So if we're going to do serology testing and saying, okay, you're cool, you don't have to worry about getting infected again, is that actually true with all forms of these genetic variations in these virus particles? So I hope I wasn't confusing through this whole process, and this isn't the typical type of presentation that I want to do. But since that came out, that's something to be aware of. And I'm always following the news and trying to follow the scientific literature and trying to think, is this something I need to call our congressman about and try to tell them, look, we need to make sure, has this testing been done before the doors get open? And I know we all want to get back to whatever was normal life before, but these sorts of things are going to change things quite a bit. You know, we've opened up Pandora's box in a sense, and we need to really invest in our researchers and our production of various testings, and you know, of course, vaccinations, and really doing good, valid, peer-reviewed, double-blind, placebo-controlled studies on medications as well. The possibilities are amazing, but we need to unshackle the resources to do this appropriate scientific research in order for things to turn out pretty well. But we all need to be respectful. Handshaking, I don't know that that's a wise thing to continue doing. I've been doing it my whole life. Keeping social distancing may be something we want to consider to continue extending, not necessarily sheltering in place once the lifts have been lifted, but trying to protect our loved ones and ourselves, and certainly investing in appropriate research for future generations as well. This is a worldwide exposure that we have nowadays. It's real easy for us to be infected with various infectious agents. I'll make another video when I get a chance about zoonotic diseases, their emergence, and what we can learn from this particular infectious disease as well. So if you found this video of value, please give us a thumbs up, share it with your friends. If you have any comments or questions, leave them below. Stay safe, people. Stay very, very safe. Work on your health. If you have a comorbidity, really focus on trying to do as much healthy eating, healthy exercise, getting adequate sleep, all of those things. Take good care of yourself, people. Your family depends on it. Bye-bye now.